For this next lesson, we're going to focus on the behavior of electrons during ionic bonding. So first we'll start with ions and then discuss that bonding type. Keep in mind with these lectures, the point of doing this is so that you have this lecture to view more than once. You can hear my extra notations more than once. You can pause, rewind, re-listen. So use that wisely. So let's start by talking about what an ion is. An ion is just a name for an atom that has either lost or gained one or more electrons. There is no change to the nucleus. The number of protons and neutrons is the same. We're only talking the electrons. So which electrons would be the ones that are lost and gained? It'll be the valence electrons, which are the ones on the outside. So only the very outer electrons can be lost or gained, which hopefully makes sense because the ones on the inside are contained within, they're sort of protected by the ones on the outside. And why does this happen? Why do they lose or gain electrons? Well, the whole point is for stability. So the less full the outer shell is, the more energy is going on with that atom, which it doesn't like. It's not happy that way. It needs to have a full outer shell to be stable and unreactive. So the different types of ions that we can have. The first is a cation. Cations are created by losing electrons on the outer shell, and this creates a positively charged ion. So it's positive because since it's lost electrons, which are negative, it now has more positive protons than it does the electrons. So there's more positive charge to it than negative. And this is going to happen with the metals on the periodic table. So any metal will become a cation. Anions then gain electrons into the outer shell to make it complete. So since it's obtaining more negative charges, overall this ion is negative, and this occurs with the nonmetals on the periodic table. So let's do a practice one just to give you some more information on this. So I want to look at calcium. So calcium on the periodic table has an atomic number of 20. Alright, so let's first consider our normal drawing of calcium. So let's do that down here. You can sort of pause and do this ahead of me. So hopefully you know how this is going to turn out. So calcium is a total of, I'm going to go off the screen a little bit here, 4 electron shells. In the first shell, there's of course our standard 2 electrons. In the second one, you have 8. There's another 8 in that third one. And then your final 2 are on the outside. So remember all the rules we've talked about with electrons so far. Your configuration should match up with this, and then also, calcium is 2 valence electrons, and that's what you see with this diagram. So calcium only has 2 valence electrons. Energy-wise, it makes sense to lose those electrons, because it's a lot easier to lose 2 than gain 6. And we'll talk more about that in a second. So calcium, once it drops those 2 outside electrons, you're now left with an ion that looks like this, and you can see it has 8 on that outside shell. So it's lost 2 electrons. So overall, this ion has a charge of 2+. Okay, so it has 2 more protons now than electrons. Because remember, atoms are neutral, protons are equal to electrons, but now we're disrupting that. So a calcium ion would be written like this, calcium 2 plus for the 2 electrons. So hopefully this also makes sense because you can see calcium's becoming a cation, which we said would happen with the metals, which is what calcium is. Okay, so when we're writing these ions, to sort of talk about what I just did, the amount of electrons that are lost or gained will be written as a superscript. So that's where that 2 came from that I wrote just now on calcium. Then the superscript will have a positive or negative with it to describe the charge of the ion. So calcium was 2 plus because it lost 2 electrons. So overall it has a positive charge. Alright, so how do the charges compare to the valence electrons? You probably noticed that based on how many valence electrons an atom has, how many electrons does it need to gain or lose to achieve a full outer shell? So typically our number is 8 to be stable, and that's what we're going to look at with the examples that we do in class. So 8's your stable number, because the 3rd and 4th shells we know can go up to more, but 8's that stable number because that means you've filled up the S and the P shells. So overall the atom's happy with that. So that's what we did with the calcium. We dropped out those 2 valence electrons, so it was left with an outside shell that had 8. Okay, so if you need to pause, go back, relook at that, think about it for a second. Now let's talk about putting that together into a compound. So atoms don't just become ions on their own. They do this in order to form a compound with something else, which is to become stable. So this occurs between a positive and a negative ion, which means that ionic compounds will form between a metal and a non-metal. Okay, so that is a rule for this. Keep that in mind. If a metal and a non-metal are bonding, it is an ionic compound. Alright, so we can see our standard classic example of sodium chloride here. Sodium is donating an electron to chlorine to give up that 1 valence electron it has. So these diagrams are just showing you the valence electrons. Chlorine has 7 valence electrons on its own. So when it gets that 1 from sodium, now it has a complete 8. Sodium's, this one would drop out and it would go down to that 1 right below it, which does have 8 electrons as well. So once you get so many of these ions together, you get sort of a complex of that ionic compound. So this is essentially all that table salt is. Alright, so some rules to figure out ionic bonding and what can go together. So start with this example, and we'll explain more on the next slide. So magnesium, its ion, it's in the same column as calcium, so it will have a charge of 2 plus. Chlorine will have a charge of 1 negative because it gains 1 electron to fill its outer shell. So magnesium and chlorine to form a compound will have 1 magnesium and 2 chlorines. And overall you end up with a neutral compound. So let's talk about that for a second. So to determine the chemical formula, which just means the ratio of metal to non-metal in your compound, there's 2 ways you can do this. One is the rule of 0 charge. So in an ionic compound, the positive charges on the metal cations and the negative charges on the non-metal anions should add up to 0. So in that last example, you had magnesium 2 plus, chlorine 1 minus. So here this 2 is coming from magnesium's charge. We're going to add that to the negative 1 charge from chlorine. In order to get a sum of 0, you know that you would need to add 2 of those negative 1 charges. So you know that your overall compound will have 1 magnesium and 2 chlorines, just like we looked at on that last slide. Another way I like to do this, I call chemistry disco, patent pending. And this is really easy. So all you would do is write your 2 ions next to each other, and then you would just swap the ions or charges, bring it down, and then that's now your subscript to say how many of each ion you have in the compound. So that 2 comes down here, this 1 comes down here, do the disco, and then you end up with this. So 1s you don't write as the subscript, you leave that blank, because you know if you just see one of these, there's only 1. And then chlorine, that 2 there tells you there's 2 chlorines in this compound. And I like to do it that way as well. Okay. So that is it for an ionic compound. Very quickly, I'm going to show you polyatomic ions, which we'll also talk about this week. So these are larger, more complex ions. And these are just composed of 2 or more atoms covalently bonded together. But overall, they have a charge. So they're considered a poly means many, atomic ion. So mostly these are going to be anions with negative charges. And here's a couple examples you may have heard of before. So hydroxide is a negative polyatomic ion composed of oxygen and hydrogen covalently bonded together, nitrate and sulfate. So here is a list of common polyatomic ions, their formula with charges, and then also their name off to the side. I would like you to remember these because we're going to refer to these all throughout the year. So if you can remember these, memorize them, it's going to be a lot easier for you. And whenever we combine these into compounds, which we'll practice later this week, those compounds are determined the exact same way as with the monoatomic ions, which are what I just showed you, which are mono, 1, so 1 atom ions. Okay, so that's everything for ionic bonding. Again, if you need to repeat anything, go back and do so, and we'll talk about this and practice this in class.